Today we're going to discuss graphing in another sense. Up to this point we've graphed points in what's called a Cartesian plane, and in that Cartesian plane we have an x and a y axis with our coordinate point being some x and y, and that's a horizontal and a vertical movement from the origin. Today what we're going to do is we're going to map something called polar coordinates. Now, a polar grid looks something like this, where we have a center and concentric circles all of different radii length in unit 1. So this is 1 unit away, 2, 3, 4, 5, 6, 7 radius lengths away. And our points are named by a radius followed by a degree measure. And you'll notice in this case that this is the point 5 and 30 degrees. So if I were to go out a radius of 5 units, 1, 2, 3, 4, 5, and rotate 30 degrees on that, that puts me at this point, which is 5 and 30 degrees. If I want to go 2 and negative 170, we've talked about negative angle measures before. So I go out 2 and rotate, instead of counterclockwise, rotate clockwise 170 degrees, which is 10 units short of 180. So that puts us right here. And you'll notice it's kind of like a coterminal angle with 2 and 190 degrees, because that's where it falls on. So this once again is 2 and negative 170 degrees. And then if I want to go, here's where the problem exists, negative 3 and 20 degrees. Well, this negative talks about a radius length, but we can't really have radii of negative measures because a radii is a unit of length long. So what this negative means is it means go the opposite direction. And if we're going the opposite direction, let's say I have an arrow pointing this way, the opposite is this way. So how is x related to y in this case? Well, if they're completely opposite, they're 180 degrees apart. So that really means add 180 to your angle. So this is really 3 and 20 plus 180, or 3 and 200 degrees. So 3 and 200 degrees would put me 3 out, 1, 2, 1, 2, 3, and 200 degrees down, which puts me right over at this point here. So this is negative 3 and 20 degrees. Finally, if I have negative 4 and 60, or negative 60 degrees, that's like again adding 180 to 60, which puts me at 120 and gives me a value of 4 and 120 degrees. So 4 and 120 go out 4, 1, 2, 3, 4, around 120, which puts me right here, and this is 4 of the negative type and negative 60 degrees. So there is a set of plots of polar coordinates. Now, we're asked next to name the point negative 2, negative 150, 3 other ways using positive and negative values for r and theta, such that the theta value is between 0 and 360. I want to plot this first. So negative 2 and 150, I want to figure out where that is. So here's my circle, and I know that since this is a negative radii looking thing, it means add 180 degrees to this. So this is really 2 and 30 degrees. And what I've done is I've actually gone ahead and already named this with a different radii and a different angle measure. So where I am is at 2 and 30 degrees right here. Now what I have to do is I have to name this using a positive radius and a negative angle measure between 0 or negative 360 and 360. So if I were to, instead of going a positive direction, move in a negative direction, I'm 30 degrees short of 360, so that would be 2 and negative 330 degrees. Now if I wanted to once again use a negative radius but a positive angle measure this time, what I'd have to do is I'd have to move 180 degrees in the other direction. So in a sense, I'd have to end up over here when I have a negative 2 radius, but in a positive angle measure. If I'm 180 degrees positively away from 30, that puts me at 210 degrees. And once again, if I were to add or subtract 180 to this 210, that makes this radii positive. So subtracting 180 from 210 gets me back to that general point. So in this next problem, we're asked to find the distance between 2 points. So here's 7 and 20. So we'll count out 1, 2, 3, 4, 5, 6, 7, and 20 degrees. And 2 and 115. So 2 out. Go around. Here's 115. So we want to find the distance between these 2 points. Now, I think personally the best way to do this is use the law of cosines. Because if you'll notice, from this center, we've really created a triangle. And we know 2 of the sides of that triangle are the radii of the 2 figures. So this is 7. This is 2. And we also have this angle here, believe it or not, because we know that if this is 115 and this is 20, the difference of 115 and 20 is 95. So that means we can find this missing side. So therefore, using the law of cosines, we have x squared equals 2 squared plus 7 squared minus 2 times 2 times 7 times the cosine of 95, which basically gives me the square root of 4 plus 49 minus 28 cosine of 95, which ends up equaling 7.45. Next, we're going to talk about taking and converting points from polar to rectangular form. So, and rectangular is like our Cartesian x's and y's. So what we have is a portion of a circle that has a polar point on it. Here's our radius and here's our angle theta. And what we want to do is change this to some x and y value. Now, wherever we are in space, even though we're calling it an r and a theta, we can say, well, that point is some horizontal distance away from an origin. So it's some horizontal out, if you will, and vertical up. Or in other words, some y value of the point up and some x value of the point out. And since we have a right triangle now, we can state that if this is x and y, we have a relationship relative to this angle using trigonometry. We can say that if I take the sine, I get y over r, and the cosine, I get x over r. With a little multiplication, we multiply our r values to the other side, and we get r sine theta is equal to y, and our cosine theta is equal to x. So if we want an xy coordinate from an r theta coordinate, we basically take r cosine theta for x and r sine theta for y. So let's convert a couple of points. We have 2250, which puts us somewhere over here, and we know that x is equal to our radius, which is 22, times the cosine of 50, and y is equal to 22 sine of 50. Now we just plug into our calculator, making sure we're in degree mode, and we get the point 14.14 and 16.85, which is a first quadrant point, which is roughly where we should be. 17 and negative 162 puts me somewhere over here. So again, I'm going to take r sine theta, or r cosine theta, and r sine theta. X equals 17 times the cosine of negative 162, and y equals 17 times the sine of negative 162. And I end up with the point negative 16.16 and negative 5.25, which puts me in the third quadrant, which is where that sketch is. Pretty simple day. There's actually no Connect Ed to do. This topic that we're covering right now isn't really in the book. We're adding something on that you're going to need next year when you move into physics in some of your science classes. So just make sure you do your summary, and we'll chat tomorrow.